Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, from the past sessions we are discussing about the characteristics of element and the variation of characteristics of the element in the modern periodic table with respect to groups and periods. So far in the discussion we have already covered with the sessions of valence electrons, valency, size of atoms, metallic character, chemical reactivity, nature of oxide, gradation of physical properties, and ionization energy. So today in the discussion we shall learn about the electron affinity. We'll also discuss the variation of electron affinity in groups and periods of the modern periodic table. So friends, let's start today's session with the electron affinity. Friends, as we have already discussed about the ionization energy, which is the energy required to remove an electron from a neutral atom of an element. As to remove an electron from an atom, energy is required. And the reverse is also true. That is, when an extra electron is added, like this, to an atom, then the energy is given out. And by taking an extra electron, the atom is converted into negative ion. We call it an anion. The extra electron goes into the outermost shell of the atom, which now we call it a electron affinity. So what is electron affinity now? Electron affinity of an element is the energy giving out when an extra electron is added to its neutral gaseous atom. As electron affinity is a measure of tendency of an atom to accept an extra electron to form an anion. Like ionization energy, the electron affinity also expressed in the units of kilojoules per mole. So now we have a proper definition, that is electron affinity of an element is the energy given out when an extra electron is added to its neutral gaseous atom. Friends, electron affinity affects the following factors, that is atomic size. As the smaller the atom is, the closer the outermost shell. Therefore, it is stronger attraction between the nucleus and the incoming electron, that is, the electron affinity is higher for the smaller atomic sizes, that is, smaller atom. Second factor is nuclear charge. As the nuclear charge also affects the electron affinity, that is, the nuclear charge, we can also say the atomic number, which is the same as the number of proton, as we all know that the protons are the positively charged subatomic particle present in the nucleus of the atom. More the protons there are, the electron affinity or the electron have the greater attraction. So the nuclear charge represent the more the proton, more is the attraction towards the outermost shell of the added electron towards the nucleus. More is the energy given out, that is, more is the electron affinity. The third one is electronic configuration. It is the arrangement of electrons in the shell or energy level or the orbit of a neutral atom. Well friends, how does it affect the electronic affinities? Electronic affinity of a stable atom with the stable configuration of an atom, less will be its tendency to accept an electron, and hence it will be lowering the value of electron affinity. For example, electron affinity of the inert gases is 0, as the atom having a stable electronic configuration in their valence shell, so there is no possibility for adding or addition of an additional electron. Also, the electron affinity of magnesium, beryllium, calcium is practically zero. This says to the extra stability of fully complete the orbits in them. Therefore, if an atom has completely filled, half-filled orbits, its electron affinity will be less. With addition to this, I'll give you some notes. Friends, please note that nonmetals typically have high electronic affinity values than the metals, as chlorine strongly attracts the electron, whereas mercury is the element with atom that most weakly attracts an electron. So the electron affinity is more difficult to predict in molecules because their electronic structure is very complicated. Friends, you should also keep in mind that the electronic affinity values only apply to the gaseous atom and molecules because the electron energy level of liquid and solids are altered by attraction with other atoms and molecules. So now let's discuss about the trends in the table. First, we shall discuss about the period in the modern periodic table. That is, the electron affinity of an element increases on moving from left to right in a period. Let us write down the values of electron affinity in the third period element to make this point more clear. As I have written here, the electron affinity of the third period element sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. With respect to their electron affinity, that is 67 kilojoules per mole, 0 kilojoules per mole, 36 kilojoules per mole, 173 kilojoules per mole, 73 kilojoules per mole, 189 kilojoules per mole, and 348 kilojoules per mole respectively. As we can see here, in the periodic table of third period, the electron affinity increases from 67 kilojoules per mole in sodium to 348 kilojoules per mole in chlorine. The increase in this electron affinity in a period is basically not regular. That is, it is actually having some bumps in between the period. That is, we shall discuss in the higher classes. The increase in electron affinity in the period can be explained as when we move from left to right in a period, the size of atom decreases, due to which the attraction of the nucleus for the incoming electron also increases. So more energy is therefore given out on adding an extra electron to atom. So now let's understand the variation in the group as the electron affinity of the element decreases on going down in a group of the modern periodic table. As we have taken the example of halogens, that is group 17 with fluorine, chlorine, bromine and iodine with respective electron affinities of 333 kilojoules per mole, 348 kilojoules per mole, 340 kilojoules per mole and 297 kilojoules per mole. As we can see here, the electron affinity of this group decreases from chlorine to bromine to iodine on going down in a group. Well, friends, please note that the fluorine element is an exception in this group because it is a slightly lower electron affinity than chlorine. As friends, this can be discussed in the higher classes as the decrease in the electron affinity on going down in a group we can explain like this, as when we move in the group from top to bottom, the size of atom generally increases and the nucleus goes deep inside the atom. So due to this, the attraction of the nucleus of the incoming electron decreases and hence the less energy is released on adding an extra electron to the atom. So friends, now we shall conclude all this session with some few points. As the electron affinity, we can say it's an exothermic process. It depends on atomic size, nuclear charge, and electron configuration. It decreases from top to bottom in a group and it increases from left to right in a period. It forms a negative ion after accepting an electron. So friends, let's conclude with the periodic table. Well, when we move from top to bottom in a group, we have a decrease in electron affinity, and when we move from left to right in a modern periodic table, the electron affinity increases. But yes, these increase and decrease are not regular, which we'll be learning in the higher standards. So friends, by this we end up with the session, and in next session we shall learn about the electronegativity. We shall learn the concept and also the variation of electronegativity in the modern periodic table with respect to groups and periods. Thanks for watching Edupedia World videos.